Okay, now we're going to talk about summation. Specifically, I want to talk about how to change the variables. What do I mean by change the variables? If you take a look at the prelim question, question 8, the first part asks you to prove by induction. Okay, I have rephrased this to cast into a summation of this expression. So suppose we have proven that using induction. Now, if we take a look closely at part 3, let's ignore part 2. Alright, I want to look at part 3 using the result in part 1, which is this. Find this. Now, if you take a look at what is in the summation, here, we are about to compare what is in this summation with the one in part 1. Looks similar, but not exactly the same. So, what is given in the printed solution, which is actually, I must stress, is the preferred method, is this. Alright? It is 1/4. What you first do is definitely to multiply the 1/4 into the summation to get this. Alright? Because 1/4 is actually 2 to the power of -2. So the only change is here. Am I right? Yeah? The only change is 2 to the power of -2. So then what we next do is to say, how are we going to link this? Can I scroll up just a little bit? How are we going to, sorry, just 1 minute, yeah? How are we going to link this summation to what we have here? So if you take a look, there is r minus 2 here, and then you have r here, and then you have r minus 2 here, you have r here. So intuitively you know they are linked, but what we suggest you all do is to write out term by term. What do I mean? First term is when r is equals to 5. So you substitute r equals to 5 into this, alright, and you get a first term, which is this. Alright, no problems. Then you sub r equals to 6, you get a second term. And on, r equals to 7, 8, 9, 10, all the way to r equals to n. Yeah, this is actually r equals to n, that signifies the last term. So, this is the last term. Then what do? We are about to link it to the earlier summation, which is this. Now, it is a little more difficult to go from here to here, difficult. But not impossible, but it's difficult. What I'm trying to do now is to write this whole here, the whole list of terms, then we are about to go from here to here, which is a lot easier actually, you think about it. Why? You ask yourself this big question. What do we substitute r equals to what such that I will get this first term? I think the answer is obvious. R must be equals to 3. Then the next term you try, r equals to 4, you will get this second term. Now, what do I substitute here as the last term? This is the last term. Here, such that I get this last term. Not difficult either. I think it's easy to see that this is n minus 2. Okay, once you reach this step, the rest is easy, because you can now link between first part and third part, except that now it's r equals to 3. Alright, you can just say that this is the difference between, these two. Now this, from here, this 2 point onwards, I am not going to go through. This one you can read all by yourself. This is, you can read. Read on your own. Alright? I'm focusing on how to do this changing of variable all the way to here. All the way to here. This is the more important part. Now this is a preferred method. As I said, it's shown in a printed solution given to you. The focus today now will be how do we use an alternative method. Notice here is an alternative method, not shown in printed solution, and may I also add that it is not preferred. Not preferred, but I'm about to show you so that you have an option if you get stuck in using the first method. Alright, but I must say that it's not preferred because of various reasons which I will mention later. And I call this the substitution method. I will call this the hang on 1 minute. Okay, sorry, this thing is moving. I will call this the substitution method. Okay, same question. Alright, we do the same thing, which is to multiply the 1/4 in, so you get r minus 2 here. The substitution method works like this, which some of you tried during your promos, maybe not as successfully, is I let r. I change the r minus 2 to r, or for this case, I don't want to confuse you, I will just let s be equals r minus 2. Another variable, substitution. Alright, I'm quite sure you're familiar with substitution. Now, which means all the r minus 2 will become s, r minus 2 will become s, r minus 1 will become s plus 1, r will become s plus 2. So this, the things inside that summation is easy. It is those that are here, the limits that you must take care of. Because when r is equals to 5, which is the lower bound here, lower limit here, s must be equals to 5 minus 2 because you are using this substitution. Alright? So, s must be 5 minus 2. Now, a lot of people forget this next step because you let us not forget let's not forget there's this upper bound which is r equals to n. So, when r is equals to n, then s must change accordingly. S must be n minus 2. Now, I cannot emphasize this enough. This step is the one that is important as well. Once you do that, then the next line becomes obvious. So I change this to s, 2 to the power s, s plus 1, s plus 2, quite obvious. Then the lower limit, as I said, this is r equals to 3 here. And this is n minus 2. This is the last term. This is for s, not for, sorry, can I change this a little? This is s. Alright? So, once you do that, then you realize that s is just an arbitrary variable. I can change the s to r. Oops, I'm sorry. Okay, I can change the s to r here. I change everything to r, no problem. You can change it to star or whatever, it doesn't really matter. And you realize that this exactly, from this point onwards, you can do the same steps as method 1. Do you follow what I'm saying? Yep? Good? Okay, so that's all. and the rest are the same. The last two lines are the same. Now, why method B is less preferred? Why? Two reasons. One, there may be careless mistakes in changing variable, especially the upper limit. What do I mean? Because this step, many people may miss out this n and just replace this n, just write it as n. No, because you remember this line that I emphasized earlier must be there. Alright? So many people will make this careless mistake. Second one, you realize that substitution doesn't work for changing in variable that involves a where coefficient of r is not 1. What do I mean? If you do this substitution and you want to find this expression using this, you realize that substitution does not work. Now, how do you know it doesn't work? You expand. If you expand this, you will realize that it doesn't work as well. Okay? I think you can try this on your own. I think you're capable of doing it. I will just say that as long as the coefficient of r and s are not the same, you have a problem. Substitution does not work. Alright? Okay, that's all. I will put this document online as well. That's all. Thank you.